How is Voyager 1 still talking to us from 15 billion miles away? It's 8 a.m. on a Monday morning. Sansa sends a signal to Voyager 1. "Good morning, send us your data." The signal travels at the speed of light, 186,000 miles per second, across 15.8 billion miles of empty space. 23 and a half hours later, it reaches Voyager 1. The spacecraft processes the command, gathers data from its instruments, transmits a response back. Another 23 and a half hours pass. Wednesday morning, 8 a.m., the response arrives. 2 days for a conversation with a machine built in 1977, a machine that's been flying through space for 48 years, a machine that's now so far away that in November 2026, just 9 months from now, it will cross a threshold no human-made object has ever reached. One light day, the point where even light, the fastest thing in the universe, takes 24 hours to make the journey. And somehow, we're still talking to it. How is that even possible? Let me tell you the story of the most impossible communication link in human history. September 5th, 1977, NASA launches Voyager 1 from Kennedy Space Center. Its mission? Fly by Jupiter and Saturn, take some pictures, send back data. The whole thing was supposed to last 5 years. 5 years! It's been 48. Voyager 1 weighs 1,600 pounds. It's about the size of a small car, and it's powered by technology from 1977, the year Star Wars came out, the year the Apple II computer launched with 4 kilobytes of RAM. Voyager 1 has 69 kilobytes of memory. Your phone has 1,000,000 times more. And yet, this 1970s relic is still functioning, still transmitting, still talking to us from interstellar space. Let's start with the power source, because this is where most spacecraft die. Voyager 1 doesn't use solar panels. At the distance it's traveling, sunlight is too weak. Instead, it uses 3 Radioisotope Thermoelectric Generators, RTGs. These are essentially nuclear batteries powered by the decay of plutonium-238. When Voyager launched, the RTGs generated 470 watts of power, enough to run a few light bulbs. But plutonium-238 has a half-life of 87.7 years, meaning the power output drops over time. Today, Voyager 1 generates less than 200 watts. That's barely enough to power a laptop, and it has to run the spacecraft's computers, transmitters, instruments, heaters, and guidance systems. So NASA has been turning things off, one by one. The cameras went dark in 1990. Other instruments followed. By 2026, only 4 science instruments remain active, and every year, the team has to decide what else to shut down to keep the mission alive a little longer. Current estimates? Voyager 1 will run out of power completely by 2030, maybe 2035 if they're lucky. After that, it goes silent, forever. But let's talk about the signal, because this is where things get truly insane. Voyager 1 transmits at 22 watts. That's less power than a refrigerator light bulb. And it's using a 12-foot dish antenna to beam that signal across 15.8 billion miles of space. By the time the signal reaches Earth, it's unimaginably weak. NASA's Deep Space Network, 3 massive antenna complexes in California, Spain, and Australia, use 230-foot dishes to catch it. And even then, the signal is so faint it's measured in billions of a watt. To put this in perspective, if you took all the power Voyager has transmitted over 48 years and combined it, it would barely light a single Christmas bulb for a second. And yet, we can still detect it, still decode it, still understand what Voyager is saying. But here's the problem: distance. The farther Voyager travels, the weaker the signal gets. It follows the inverse square law. Double the distance, the signal becomes 4 times weaker. Voyager is now so far away that its signal is approaching the noise floor, the background static of the universe. And it's getting worse. Every second, Voyager 1 moves 10.6 miles farther from Earth. Every hour, 38,000 miles. Every day, 912,000 miles. In November 2026, Voyager 1 will hit the 1 Light-Day Milestone, 16 billion miles from Earth. A signal will take 24 hours to reach it. A response will take another 24 hours to come back. If something goes wrong, if an instrument fails, if the antenna drifts, if a thruster misfires, NASA won't know for a full day. And by the time they send a fix, another day passes. 2-day lag for every command, 2-day delay for every emergency. And this is happening right now as you're watching this. Voyager 1 is out there hurtling through interstellar space, and we're communicating with it on a 2-day delay using 1970s technology. But it gets worse, because Voyager 1 almost died multiple times. In November 2023, Voyager 1 stopped sending usable data. The signal was still there, but it was gibberish, ones and zeros in a repeating pattern, like a broken record. NASA spent months trying to figure out what went wrong. Was it the computer? The transmitter? Had we lost contact permanently after 46 years? Finally, they figured it out. A single memory chip in the flight data subsystem, one of the spacecraft's 3 computers, had failed, likely hit by a cosmic ray or just worn out from age. Now here's the problem. You can't just replace a chip on a spacecraft 15 billion miles away. So NASA did something incredible. They rewrote the software remotely. They remapped the 1970s code to bypass the broken chip entirely. It took months, but in April 2024, they did it. Voyager 1 came back online, started transmitting science data again. A 48-year-old spacecraft with a broken chip fixed remotely from 15 billion miles away. And this wasn't the first time. In October 2024, Voyager 2's antenna drifted slightly out of alignment. The signal was lost, but the spacecraft's autonomous systems detected the error and corrected it without human intervention across 12 billion miles of space. These spacecraft are survivors, and the team keeping them alive, they're working with computers that have less memory than a single tweet. Now let's talk about what Voyager has actually discovered, because this is why we're still talking to it. Voyager 1 flew by Jupiter in 1979. It discovered Jupiter's faint rings, found active volcanoes on Io, the first active volcanoes ever seen beyond Earth, photographed Europa's icy surface, hinting at the subsurface ocean we now know exists. Then Saturn in 1980. It studied the rings up close, discovered shepherd moons, tiny moons that keep the rings in place through gravity, measured Titan's thick nitrogen atmosphere. And then it kept going, into the unknown, into the space beyond the planets. In August 2012, Voyager 1 crossed the heliopause, the boundary where the sun's influence ends and interstellar space begins. It was 11.6 billion miles from Earth, the first human-made object to leave the solar system. Since then, it's been measuring interstellar space, the magnetic fields, the cosmic rays, the density of particles between the stars. Data no other mission can provide. Data we'll keep getting until the power runs out. And here's the haunting part. Voyager 1 will outlive us, all of us. Even after it goes silent, it will keep flying, drifting through the galaxy at 38,000 miles per hour. In 40,000 years, it will pass within 1.6 light-years of a star called Gliese 445. In 300,000 years, it will reach the Oort cloud, the shell of icy objects surrounding our solar system. And strapped to its side is the Golden Record, a 12-inch gold-plated copper disc containing sounds and images from Earth, music, greetings in 55 languages, pictures of humans, animals, landscapes, a message to anyone or anything that might find it. This is a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so we may live into yours. Voyager 1 is a time capsule, a message in a bottle thrown into the cosmic ocean. And one day, maybe millions of years from now, someone might find it. But for now, we're still talking to it, still sending commands, still receiving data. A conversation across 15.8 billion miles with a machine that was supposed to die 43 years ago. So how is Voyager 1 still communicating with us? Incredible engineering, nuclear power, massive antennas, the inverse square law barely holding together, software updates sent across interstellar distances, a team of engineers who refuse to let it die, and maybe just a little bit of cosmic luck. In November 2026,
In 2017, NASA's Cassini spacecraft recorded radio emissions from Saturn and converted them to sound. What you're hearing is a planet-sized magnetic field being battered by solar wind, auroras crackling across the poles, and atmospheric storms that could swallow Earth whole. And for decades, we looked at Saturn and saw beauty, the golden crown of the solar system, the jewel with perfect rings, the serene gas giant floating peacefully in the outer darkness. We were looking at a gravitational executioner and calling it beautiful. Let me show you what Saturn really is, and why the most stunning planet in the sky is actually one of the most violent, unstable, and dangerous worlds we've ever encountered. First, the rings. Everyone knows Saturn's rings: majestic, pristine, eternal. Except they're not. Those rings are made of ice particles, rock fragments, and dust, ranging in size from grains of sand to house-sized boulders, all traveling at tens of thousands of miles per hour. They're not floating peacefully. They're a high-velocity debris field held in place by Saturn's crushing gravity. And in some places, those rings are only 10 meters thick. 10 meters, thinner than a 6-story building is tall, stretching hundreds of thousands of kilometers across. And here's the thing nobody tells you. Those rings are probably the shredded remnants of a moon. Billions of years ago, a moon wandered too close to Saturn. It crossed something called the Roche limit, the distance where a planet's gravitational force becomes stronger than the moon's own gravity holding itself together. And Saturn ripped it apart. The moon didn't explode. It didn't crash. It was slowly, methodically torn to pieces by tidal forces. The side facing Saturn was pulled harder than the side facing away. The moon stretched, cracked, disintegrated, and what's left is the glittering debris field we call rings. Saturn's beauty is built on destruction. But it gets worse. Those rings, they're dying. Scientists discovered something called ring rain. Saturn's magnetic field is dragging charged ice particles from the rings down into Saturn's atmosphere. The rings are slowly bleeding away, vaporizing into Saturn's clouds. At the current rate, Saturn's rings will be gone in 100 million years, which sounds like a long time, until you realize Saturn is 4.5 billion years old. The rings are temporary, a cosmic blink. We're living in a brief moment when Saturn happens to have rings. In the deep past, it didn't. In the deep future, it won't. We're watching a planetary death in slow motion. Now let's talk about the hexagon. At Saturn's North Pole, there's a storm, a massive churning jet stream with winds exceeding 200 miles per hour, and it's shaped like a perfect hexagon. Each side of the hexagon is longer than the diameter of Earth. The entire structure is over 20,000 miles wide, and it's been there for at least 40 years, maybe longer. We don't know. Voyager 1 first spotted it in 1981. Cassini studied it for 13 years, and the hexagon never moved, never distorted, never broke apart. On Earth, hurricanes last days, maybe weeks. Jet streams shift constantly. But on Saturn, there's a geometric storm that's been raging for decades, possibly centuries, locked in place like a scar on the planet's face. Scientists couldn't explain it for years. How does turbulent gas form a perfect six-sided shape? Why doesn't it dissolve into chaos like every other storm in the solar system? Then, in 2020, researchers at Harvard and Caltech figured it out. The hexagon is deep, not hundreds of miles deep, thousands of miles deep. It's a supersonic jet stream originating from pressures tens of thousands of times greater than Earth's atmosphere, pinched into shape by a ring of smaller cyclones spinning in the opposite direction. It's not a surface storm, it's a wound extending into Saturn's interior, and it's been screaming for longer than human civilization has existed. But wait, in November 2024, the James Webb Space Telescope observed Saturn for 10 hours in unprecedented detail, and what it found was terrifying. Dark beads, strange bead-like structures in Saturn's ionosphere that scientists have never seen on any planet before. They appear to line up with an asymmetrical star-shaped pattern deeper in the stratosphere, and both might be connected to the hexagon thousands of miles below. Scientists have no idea what's causing them. One researcher said these features were completely unexpected and at present are completely unexplained. Saturn is hiding atmospheric processes we don't understand, structures that shouldn't exist, patterns that defy physics, and they're all linked to a storm that's been stable for at least 40 years. Now the Great White Spot. Every 30 Earth years, roughly one Saturnian year, a massive storm erupts on Saturn. It starts as a bright white spot and grows, spreads, wraps around the entire planet like a scar encircling a wound. The last one happened in 2010. It lasted for months. The storm grew so large, it eventually wrapped all the way around Saturn's equator, a planet 9 times wider than Earth, and collided with itself. Inside these storms, lightning strikes with 10,000 times the energy of lightning on Earth. The winds reach hundreds of miles per hour. The clouds boil and churn with such violence that the heat signature can be detected from 1 billion miles away. And it happens like clockwork. Every 30 years, Saturn erupts. We don't know why. We don't know what triggers it. We just know it's coming. And when it does, the entire planet becomes a war zone. But let's talk about the moons, because Saturn doesn't just destroy with gravity. It hides things. Titan, Saturn's largest moon, bigger than Mercury, the only moon in the solar system with a thick atmosphere. From a distance, it looks like an orange Earth, clouds, haze, weather systems, lakes and rivers. Except the atmosphere is nitrogen and ethane. The surface temperature is negative 290 degrees Fahrenheit. The lakes aren't water, they're liquid methane and ethane, and the atmospheric pressure is higher than Earth's. If you stood on Titan without a spacesuit, you wouldn't explosively decompress like on Mars. You'd freeze solid in seconds while toxic methane rain fell from the sky. Titan is Earth's evil twin, a hydrological cycle, seasons, rain, rivers, clouds, but everything that makes Earth alive would kill you instantly on Titan. And then there's Enceladus. Enceladus is tiny, barely 300 miles wide, a frozen snowball orbiting Saturn. For years, scientists thought it was dead, just another icy rock. Then Cassini flew past in 2005 and saw something impossible. Geysers, massive plumes of water erupting from cracks near the South Pole, shooting hundreds of miles into space. Enceladus has a subsurface ocean, liquid water trapped beneath miles of ice, kept warm by tidal forces from Saturn's gravity, constantly squeezing and flexing the moon's interior. And that ocean is spraying into space through cracks in the ice. Scientists analyzed the plumes, water vapor, salt, organic molecules, everything you'd need for life. Enceladus might have life right now, swimming in a hidden ocean beneath the